the kids will have done module 1. Okay, now we're recording, huh? Okay. The kids will have done module 1. And so they've got some idea how Star Logo works and what different parts of the code are. And they should be able to decode a model fairly easily. We have a blocks guide for you. Lots of teachers print that out, laminate it, cut it up, and then pass out the different sections to a couple of students and have them explain it either in writing, or especially if you have Smartboard or something like that, have the kids come up and walk the rest of the class through their part of the model. And they can do this in the 4th grade. They can, and don't let them just read you the code and say, well, when setup is pushed, create 10 rabbits. Make them explain what it means in lay terms. And then the first activity really in lesson 2 is to think about and run an experiment with this model. And at this point, we don't really want them to build any code. We just want them to think about, well, what if we started with 3 times as many rabbits, go in and make that tiny change, and then see what happens. And you want to be sure to emphasize with your students that they need to remix the model before they change anything, so that if they're comparing the original to the changed one, they're not having to change it back and forth. They've still got the original, and when they remix it, now they have a new one that does something slightly different, and they're ready to go. And so decoding the model, they want to use the model observation form to preview and decode. And then to run the experiments, they want to use the experimental design form. I'm sure you're all experienced teachers, so you have to make the kids write down what they want to do before you let them play on the computer. Otherwise, they'll entirely skip that step and just play with the code. So I usually have the experimental design form as their ticket to go in and change the code. Any questions so far about that form or what we've talked about in the first 2 lessons? Let me, now and then I'll check the chat window to see if there are any. Okay, see any new questions there yet? All right. We good? All good?
Yes. Yes.
Okay. Okay, so lesson 3, I think, is where probably a lot of you are. Some of you have finished this already, but lesson 3 is where the kids go in and add some code. They add a predator to the model. We use a mountain lion in ours, but if you've wanted to customize your model at this point to be some other ecosystem that's more relevant to you, that's absolutely fine. The students need to understand how to add a breed, how to give that breed a trait, and you want them to be sure to name the trait something different than the rabbit trait. Please don't name it energy. Name it predator energy or lion energy or something like that. And then really, the simplest way to add your predator is once you've created the breed, you've given it a trait, you've added it, you've created a couple of them on the world tab in your with your create block. Then go on the rabbits page, cut and paste, copy and paste all the code onto the lion page, and then go through very carefully, step by step, and rename every procedure and be sure that it's calling, anytime you're talking about the lion energy, be sure you're calling lion energy and not rabbit energy. The computer will get mixed up if the rabbits run and if the rabbits hop and the lions also hop. Even if the hop procedure is different on the lion page, you're going to get a weird result. So you need to be sure that the procedures are named differently and that they're calling the thing for the relevant breed. But really, it's pretty simple coding if they'll carefully go through and do that to add the predator. It's a little tricky to get the predator to live long enough to be able to eat some rabbits. A very common coding error at this point is to add a single predator, not give it enough energy, and so it'll disappear in 3 or 4 steps, and then you don't have any more lions. So I recommend you create at least 3, give them a fairly high energy level to start with, and give them a pretty good bump when they eat a rabbit. Don't give them just one, because there aren't that many rabbits. They have to move a long way to get one. But anyway, it's a fun activity for the kids to do, and it's easy for them to understand. You know, ecosystems is something they're pretty familiar with by middle school anyway. And so this is a really easy entry-level model. Any questions? Oh, and then the second part of adding a predator is to go back to your experimental design form now and design and run an experiment with your predator. So you want to really be comparing the model with the predator to your first model without it. So again, be sure that you're remixing it to add the predator, and then think of a simple experiment that you can compare. So really, what the experiment hopes to show is that if you have a fairly stable predator, you should be able to get your ecosystem much more stable than it will be with just rabbits and grass. It's very hard to balance the system with rabbits and grass and keep the lines on the graph crossing. Usually either the grass dies quickly and then the rabbits die, or the rabbits all die quickly and then the grass explodes. When you add a predator, you should be able to balance it a little longer. So that's the goal. Does anyone have questions about adding a predator, problems that you've run into in your models? Let's see if we have any new chat questions. Okay. Okay, how to copy the code. Yeah, it works best with the copy function in the program. At the bottom of the blocks drawer, there's copy and paste. So you do like a screenshot, you drag a green box around the code that you want to copy. And it will copy it like a procedure, a block of code pretty easily. It's much harder to get it to copy part of a code that's connected to other parts or part that's overlapping. So be sure you make your green box around the whole code you're trying to copy, and then it's easy to do. Okay, everybody pretty good with adding predators? Any questions so far? All right, lesson 4 is where it gets to be fun, because you want your students to do something more. How can they make this model more relevant to whatever ecosystem you're studying? Do you want them to add a trophic level, like an intermediate predator? Do you want them to change the behavior of the lions and the rabbits so that the lions chase the rabbits instead of just randomly wandering around and bumping into them? Do you want the rabbits to run away? That's all very fun and pretty easy to do in Star Logo Nova. The code for that is not very complicated. And then you can talk about things like, realistically, how do you balance the system? I mean, obviously the lions are going to run faster than the rabbits, but maybe the rabbits have a better sense of smell, and so they can smell the predator from farther away. And things like that, just to make it realistic and more fun to have it work, because you want to see a difference between the times when the lions and rabbits just randomly wander around and the times when they are actively chasing or running away. You can make the rabbit sense the grass. You can add a predator, you can add a competitor for the rabbit that also eats grass. And a popular one for kids is to talk about an invasive species. So do you want to add tumbleweeds that crowd out the grass and give the rabbits less energy, or something like that's relevant to wherever you live? And again, here we are in lesson 4, requiring the kids to write out their project design before they start making the changes in the code. And we really emphasize this. Not only does it require them to think through their project, but it also prevents tremendous problems in coding if they've written it down and haven't forgotten what they meant to do or haven't planned something that's really going to be difficult. A lot of students want to make it 3D, much more of a 3D model like fish in an ecosystem, which is not ridiculous. It's not that hard, but it does make it a little harder for them to collide with each other if they're not at the same Z coordinate. So that is one that doesn't get you a lot farther in the science, although it does get you farther in the coding. And so you can look at their designs and see, is this really teaching them the science concepts that I'm trying to get across in my class? Or is it really just having fun with the computer? And at this point, you have to go back to your judgment as a teacher, because you'll get several project designs where they say, some kids will want to say, well, what happens if we change the lions into bears? And the answer is, it's not going to make any scientific difference at all if that's all you're changing is the color of the lions or something like that. Other kids are going to want to, try to solve multi-species extinction issues due to climate change, right? Something that they're not going to be able to accomplish in the time that you're going to have to devote to this in class. So in the project design form, you're looking for the fact that they filled it out and thought through their idea. You're looking for an appropriate scope of project. Is it something that makes a difference and something they can accomplish? And the final thing, which is hard, I find the hardest to get across to the kids, is that they want to be asking a question that their model can answer for them with some kind of data that they can collect. So, how many times out of 10 does the rabbit population crash under certain conditions? How many ticks of the clock can I get the model to run until one of the species completely dies out? Something like that they can see on a counter or on a graph, or, how long does it take the lines to cross, or how many times can I get them to cross within 300 ticks, or something that they can measure, because that's really the goal of this, right? Is they're running a science experiment with their model. They're measuring the difference between one thing and another. So when they move their slider, what changes that they can measure, right? And there are some tricks to that about when you get a little more sophisticated in the coding, about making the program stop when certain things happen. Like, for example, if one of your species dies, the whole thing stops, so that you don't have one student with their hand on the mouse trying to click off the forever when whatever it is that they want to happen happens. You can make the computer do that. You can make it stop. You can make it stop stop after 300 ticks, stop when one of the rabbits dies, stop when the population is exactly equal. Whatever your condition is that you're wanting to measure, see if you can think through a way to have the program automatically help you with that, so that the students are just really running their experiment, making it run as fast as the program will run, and then recording a number, and then starting it again and recording a number, average the numbers after 5 trials or 3 trials or whatever you have time for, so that they're getting the idea of using an average, using multiple trials, and coming up with data that answers their question. If you introduce an intermediate predator, is the system more stable? That's your basic question. And if so, how can you measure that? The answer is, how long does it run before any one species completely dies out? It's not that hard to compare that from the just plain rabbit grass predator to rabbit grass squirrel predator, or rabbit grass tumbleweed predator, or whatever your new condition is. And then the last idea in lesson 5 is that the students present their project, or at least prepare it to be presented. And again, that's up to you as teachers about how you want their final project to be. We find that kids get a lot of good ideas about coding that they hadn't thought of, and that you may not have time to kind of go through and share with the class when they see other students' presentations. We encourage them to present very quickly their model, to explain one piece of code that's different or interesting, and then to present their data. So that is pretty much ecosystems. What questions can you ask me about it? When you have a question, you can either put it in the chat window, or you can unmute your mic and ask me. Much faster. That's interesting. But, yeah. Okay, I'm just reading the questions in the code, in the comments. Okay. Oh, okay, now we're back into Melody's questions. Good, because those are about chemistry, and that's too hard for me.
Okay, you have a new question from Mark, I think.
Oh, okay, there we go.
Monica?
Is there a way to introduce a predator species at a certain time to kill off an invasive species? Yes, there are a couple ways to do that. One is you can make a new widget. You can always make more widgets to go on your interface page, and you can make they can be push button widgets, or they can be toggle widgets. Push button widgets are like the setup, like a doorbell is what I tell the kids. You push it once, it rings once. End of story. You push it again, it rings again. As compared to a toggle widget, which is like a light switch. You turn the light switch on, it stays on until you turn it off again. So you could put a new toggle widget that would create your predator. And then you have your predator behaviors existing on your page, but until you create them, there's nobody to do it. So you could do it manually like that by pushing your introduce a predator button whenever you're ready for them to happen. The other thing you can do is you can always put a condition inside a procedure or a button. So for example, if clock is greater than or equal to 300 in a toggle button, create one predator. Well, actually, you could do it in a forever button too. Create one predator and then reset the clock. Or April did this in her model by giving a trait to something. So, So you could say, actually, let me step back a minute, because I think there's an easier way to accomplish what you may be wanting to do here. You can say, if count tumbleweeds is greater than or equal to whatever your initial condition is for tumbleweeds, create one predator, and that would be inside your inside a toggle button. What's a little bit dangerous, and the reason I'm trying to think through this carefully, is that Star Logo Nova is pretty flexible about how many agents you can have. You can have a few thousand, but if you get too many, and the old version of this, too many was somewhere between 4,000 and 5,000, your computer really starts to slow down, and if you get too many, it crashes. And the easiest way to get too many is to have a create inside a forever loop, because it once, say, if your tumbleweeds get over 300, you create a lion. If that's in a forever button, you're going to create lions until your number of tumbleweeds drops down. It's going to do it every tick of the clock. So you want to think about a way to create your predator only once when a certain condition exists, and then either reset that condition so that it only exists that way. So for instance, if you had a condition in your rabbits that said rabbits age, and they age every step, then you can make them die, just like you've done with energy. You can make them die when they get to a certain age, or make them only reproduce when they get to a certain age. But if you do that in, like, let's say, for example, your reproduce procedure, you want the rabbits to only reproduce if they're 5 years old or older, and you want them to die if they're 20 years old. So you put your reproduce procedure, you set your rabbit age on setup, you increase their age a little bit every tick. When they get to 5, you allow them to reproduce, but you still have the reproduce code. You still have if you have a slider to have them reproduce, or you have energy, you don't want them to automatically reproduce every tick between 5 and 20, or you have them reproduce and then you reset their age. Once they reproduce, they have to start aging again. Something like that, so that there's a condition that makes something happen, but there's also a limit on that condition getting reset. And if you look, let me see if I have rabbits, and let me get rabbits and grass open here and give you a better idea of what I mean, because I think the longer I talk, the more confusing it gets. So let me open up a rabbits and grass model. Actually, let me do it from the Project Guts page, so I'm sure to get the right one. So module 3. These models are also all on the Project Guts page. You can find them from there. Okay, so this is the basic rabbits and grass model. And here's an example of one kind of a condition on the grass page. Let me go back and share my screen here so you can see what I'm talking about. There we go. All right, can you see that now?
Yes.
Okay, thank you. All right, so on the grass page, the grass only sprouts, each grass has basically a 2 in 200 chance of sprouting every tick of the clock, because sprout is called in a forever. So each grass is going to sprout roughly every 100 times. So that limits it right there. It only sprouts that often. And then the rabbit reproduce procedure has a better example of what I'm trying to talk about. So if my rabbit energy is greater than or equal to 5, I want to reproduce, but the first thing I'm going to do is decrease my energy now in this procedure so that they don't reproduce like rabbits. Otherwise you get a rabbit population explosion and it crashes your model. Kids think this is funny until they do it once and then they have to rebuild it. Sometimes they're open and it doesn't have all the changes since the last time they made it, and they realize it's not that much fun. So you only create a rabbit after you've reset the energy. And this is what I'm trying to suggest for any kind of a condition where you want something to happen. You could put a procedure in your forever loop over here if it has a limit on it. So if it will only be triggered on a certain event, and then whatever was the condition for that event immediately gets reset. And so it doesn't work as well with count whatevers. You know, you could still only have the grass reproduce if there were under a certain number of grass agents. You could say if count grass within 200 steps is less than 100, then you would have this random chance of reproducing, or maybe a higher random chance. But you can put any kind of condition on something to make it happen later in the model. Or you can make it happen when the clock equals a certain number, not greater than or equal to, but equal. If the clock is equal to 300, then make a predator. And then your predator will behave the same way, whatever you've told it to do, but it won't show up and be doing that until you add it somehow into your model.
Hey, Sue, you have 2 questions. Well, one is a request. Do you have any sample codes you could show us that do different things to give us ideas? I was wondering if you wanted to show a chase and run away.
Sure.
And then the other question was from April, I think, and it says, explain. Okay, how do I know? Yeah. What blocks are in which drawers? For example, the stuff in environment doesn't seem environmental.
Right. And some of the things are not logical and you just kind of get used to them. So let me answer that question first and then I'll switch to a different model. So the first thing to notice is that the blocks, let me share my screen again. I'm talking away here and you can't see what I'm saying. Okay. All right. So the first thing to notice about the block drawers is that they're in alphabetical order until you get to the last one, debugger, and don't do variables or debugger with middle school kids with only this amount of time. You don't need them and it just confuses them. The second technique we have is to, if possible, print out or project that blocks guide that shows what color things are. because things are mostly the same color in the same drawer. And so if they see something that they want to replicate, they can look and see, okay, the create drawer, the create block must have come from the agents drawer because that's where the orange blocks are. Hopefully in the next version of Nova, this list is going to be color coded. And that will really help if it is. But the environment, what they're talking about is the terrain, this green square. So things that relate to the green square, changing the color, stamping the ground, clearing the green square, marking on it. The clock is the one that confuses me. It doesn't seem in a logical place to me. But when you work with it, you learn to find the ones that you use the most often. I talk to kids about the interface. This whole screen, not just the green part, is the interface. So if you want any code about widgets or graphs or data boxes, because those things appear on the interface, they appear in the interface section. The others that you use most frequently are logic. And this one, kids will try to put any kind of block in here and it won't fit. It won't go in there. Nothing will go in there except another gold block. So if you are doing something in logic, you can't leave this drawer until you pick one of these things. They're really Booleans is what they are. So I hope that helps with the drawers, but we use that block guide a lot. A lot of teachers will print out, especially if you're pair programming and your biggest class is, let's say you live in Nevada and your biggest class is 45, then you only need to print out 23 copies of that on your color printer, laminate them, and give them to the kids. So there is, let me just stay on sharing and skip to, I believe it'll be in here, create your own ecosystem, a link to how to chase and run away. And there are a few, oops, that's not what I want. Okay, here's another trick you can use. If you're on one Project Guts model and you want another, you can go over here and get the whole gallery for those models, all the public models. Okay, so there's Rabbit's Grass and Mountain Lion with Chase and Run Away. So I'll open that one and just show you that part. Okay, so here's the mountain lion chase procedure. First of all, notice that in my forever toggled, I don't call the run. I don't call mountain lion run. And I'll show you why as we go through this. So in the chase procedure, each mountain lion can, and in the old version, they called this smell, which makes sense because you smell in every direction around you. It doesn't matter which way you're facing. So they look in every direction within however many steps you tell them. And if there are any rabbits, if the count is greater than 0, then they turn towards the nearest rabbit, they face directly at it, and go forward 1. Now, I've made the lions lose a tiny bit more energy when they're chasing a rabbit than they do when they're just running around at random. If they don't see any rabbits close enough to chase, then they call the run procedure, which is just a random wiggle. Okay, does that make sense? And then let me show you the rabbit procedure, which is just one tiny step more complicated. So again, the forever doesn't call the hop for the rabbits, it just calls the runaway. And they also look for mountain lions. I have them having a much less, oh no, the mountain lions are smelling within 10 steps. And the rabbits are only smelling within 5 steps. So the lions are creeping up on the rabbits. And there's no face away. So they have to look at the lion and then panic and turn around and then start moving straight forward. So they're running directly away from the lion. They're losing a little more energy as they run away. And if there is no lion, then they hop. Okay, so that's one that has chase and run away.
Will you
Yeah.
run that for us? Will you run that code for us?
Oh, sure. Yeah, it's fun to watch. Let me zoom in a little. And let's see, make sure that we can see. There's a lion there. There's another one. I don't think those are, maybe those are squirrels. Let's see. Okay, well, we'll try it. Oh, there's the lion is up in the upper right corner. So let's watch. So you can see that the lions, and they're supposed to be rabbits, but they look like squirrels in this model, are just roaming around at random until the lion is going to get close enough to a rabbit. Ah, there he goes. Now, oh, see the rabbit turn around and run away? Ah, there, see it? But now my lion died, so I'm going to get a lot more rabbits. Okay? All right, let's see if we have any new questions. Okay. Ah. Yeah. Okay. Okay. The other, so besides using chase and run away, which is fun and it adds a little more reality into the ecosystem, let me give you one warning about that is if you want one breed to move faster than another one, but you're relying on collisions, it will mess up your collisions if you have them move more than one step at a time. Yes, Monica, I'll get to that in just a second. So if you want, let's say you want the rabbits to have a good sense of smell compared to the lions, but you want the lions to run faster, make the rabbits go forward a fraction, a decimal, 0.5 steps or something like that, and the lions go forward 1. If you make any breed go forward more than 1 at a time, it won't collide. It will just jump over the other one. If this one is going to move 2 steps, it will move straight through it and not collide. It will only collide if they land on the same space. So if your program relies on collisions, you have to be careful to not have any agents move forward more than 1 step at a time. But they can move a decimal of a step. Okay, so let me go back to let me share my screen again. Where did that go? And go back to how to copy and paste. Okay, so let me find a nice procedure with nothing in the way. Okay, so I want to copy this collide. I just click my mouse and draw a green box around it. See it change color. And then I click copy. And if I want to paste it onto another page, then I click paste. Here is another trick. It will always paste it in the extreme upper right-hand corner of your code. So you have to go looking for it. So now if I want my mountain lions to eat grass, there we go. they're all set. And cut works the same way. It doesn't work. The kids try to copy, for example, that part of the procedure. And if it's highlighted like that, you can try it. But sometimes it gets all the code you want. See, that time it didn't. It only got the conditional block. And I was thinking that I was going to copy the whole thing. So I personally always use the green box method. Okay. Let's see if we have any other questions. Oh, so extraneous code won't stop the program and overlapping won't either. Some blocks will give you an error message. Empty socket detected in block 0. It always says that. Block 0 helps you not the slightest bit, but some blocks will do it and some blocks won't if they're just kind of hanging around there somewhere. So generally the conditional logic blocks will stop your code, will give you an empty code message. But if you just have, for example, say a traits block, set my color to, and you don't have it connected to anything and it's not doing anything frequently, it won't give you that message. I'm kind of a perfectionist about making kids throw away the useless code in their model just that they're not using anymore. There's plenty more where that came from. The block drawers never run dry. So they can always just go back and get it again if they don't want it. But empty socket messages are frustrating because they're hard to find. And you will get one also. I'll share again and go back. You will get one. So for example, if I leave that disconnected, oh, you know what? It's not going to matter because I haven't remixed this model. So let me try remixing it. I tell kids this, they're afraid that other people are going to break their models if they put them in a public gallery. And in fact, they can't. Notice that I didn't have a save button up here until I remixed it. So let me just, yeah, it's still broken. So let me save it. And then when I hit run code, no, it didn't do it that time. No, it's still working. Okay. So that did not give me the error. I was trying to get something that would give me that error message, and that was not it. How about if I put this in there and try it again? Now I'm asking it to do something without telling it what it is. And there it is, the evil error message. It always says block 0. You have to click OK before you can do anything to try to fix it. But see that I'm asking it to do something and not telling it what to do. If I just have an extra block out here that's not connected to anything, it probably won't change my results. And sometimes what's happened is that there's a block hiding behind something else. So one way to look for that error message is to grab the whole thing and make sure everything moves with it and there's nothing hiding behind it. And the other thing, another frequent cause of it, is if what you've said doesn't make sense. So for example, if you say in your create, set my size to raccoon, if there's a mismatch, nope, that didn't do it. Sometimes those mismatches will cause it to give you the error message, or sometimes the block will be not quite clicked in like I have it now, and it will give you that error message. So just moving your code around, looking to make sure there's nothing behind it, that there's nothing that's not clicked in, and checking all of your drop-down arrows. that there's something selected in every arrow. Even when there's only one choice, if you don't select something, sometimes you'll get that message. Okay, let's see if there are any. Yeah. Any other questions? We have 5 minutes. Anybody have any last concerns about Module 3 or about anything in your code? Okay, let me just take a quick look at who's here. If I had anything that I knew I wanted to say to anybody else that's on here. No, I don't see it. Okay, well, I think I can let you go 5 minutes early.
Thank you, Sue.
All right, thank
All
you,
right,
Sue.
thanks everybody.
Thanks, everyone.
All right, bye. Thank you. Bye-bye.